Hello friends, today I'm going to solve LeetCode problem number 295, find median from data stream. What is a median? A median is a middle value in an ordered list. So let me just show you here. We have an ordered list, suppose 1, 2, 3, 4 and a 5. So in this case our median is the middle value. And what's the middle value? This is right, this is the middle value because there are equal number of elements to its left and to its right. So this is our middle value and this is our median here. Now in case we have one more element in this list, then the total number of elements in this list, it becomes even, right? And in that case 3 is not the median value because the number of elements to its right, which is equals to 2, is not equals to the number of elements to its left. At that case the median is equals to the average of these two elements. Basically these two elements are the middle elements of this list, right? And we take the median by taking an average of these two elements. So that is how we find our median in a list. Now what we are given here is we need to implement the median finder class. So we are going to implement this class and we need to initialize our median finder object in our median finder function. And in the add norms function we are going to add the integer norms from data stream to the data structure. So basically in this function we are going to initialize our class. So basically we are going to define the data structure that we are going to use to add the integers to that data structure and then find median from the data structure. So basically there are just 3 steps. Define data structure. Here we are gonna initialize everything and then add norms and find median. So how could we solve this problem actually? So let me just show you how we could actually solve this problem. So we need to first of all define our data structure, right? Data structure which would store our stream of data, which would store our data. Now one of the data structures that we could use is an array. So in an array we need to store our data in a sorted order. Basically our data always needs to be sorted because we need to find our median value, right? To find our median. So to find our median we need to sort our data. So suppose the first element in the data stream is equals to 2. So in our array we are just gonna add the value 2. So we are just gonna push the value 2 because initially it's empty, right? Next element in our data stream is equals to 4 and we know 4 is greater than 2, so we just push the element to the end. Now the third element is equals to 3. We know 3 is greater than 2 and less than 4, right? Which means that 3 should go right in the middle of 2 and 4. So for this we can actually use binary search to find the index to store our new element. And then once we have found the index we actually need to insert that element here, right? So for that we are going to use splice method in JavaScript. So splice method would insert our element at that index. So index we are not going to remove anything, so this will be 0 and then our value which is equals to 3 in this case. So this is how we could actually insert our elements in the data array. And talking about the time complexity, binary search will take big O of log n time complexity, and the splice method, it takes big O of n time complexity. So in total our time complexity is log of n plus log of n. So let's code this solution first of all. So this dot array equals to our array, and here if this dot array dot length equals to 0, then this dot array dot push, we're just gonna push our element into the array. If not, we need to perform binary search, so our left index will be 0, our right index will be this dot array dot length. We are taking our length, our right index to be the length and not length minus 1, because let's say in this example, suppose this is our array so far, and our next element to be inserted is 4, and we know 4 is 4 will be inserted at the very end, right? And the index of that would be 0 1 2 3. So basically we are inserting 4 at index 3, and so far when we have only this many elements, the size of the array is equals to 3. So basically the size of the array will be the index for our new element if it is the greatest one. If not, we are just gonna do the binary search here. So now while left is less than right, what we are gonna do is, if our value is less than the array, the middle value, okay, we need to find our middle value first. So let m equals to math dot floor left plus right divide by 2, and then if it is less, which means that suppose this is our array, right? And the value num is equals to 2, and we know here our middle value is equals to 3, and num, which is equals to 2, to be inserted is less than 3, right? In that case our right pointer should move to the left. So our right is equals to middle value else left equals to mid plus 1. And then finally in this case, let's for 2, when we have moved our right here, our left is still here. Now our new middle value is index 0, and in this case 1 is greater than 2, right? So our left is equals to mid plus 1. Now our left and right both are equal, right? And at that case we are gonna splice our array, splice at index left, and then remove 0 elements and add our new element, which is num, to the array, and this will basically create our new array here. So let's see, in case where do we need this line here or not? So we are actually so this is when the length is equals to 0, right? Which is when we have no elements in the array. So suppose when there are no elements in the array, if we erase this, what will be the case? Well, right will be equals to 0, because length is equals to 0, right? So 0 is equals to 0, left and right both are 0. This while loop won't be executed. So left, which is equals to 0, so basically we are inserting our value at position 0. That's absolutely fine. So basically we do not need this element. Now let's check in case when we need to insert a second element. Suppose our new element to be inserted is equals to 2, So before inserting 2, our length is equals to 1, right? So right is equals to 1, left is equals to 0, and at that point of time mid is also equals to 0. So when mid is equals to 0 and our value num is equals to 2 is greater, right? So at that time left plus 1, left is equals to mid plus 1, so left is equals to 1. And when left is equals to 1, it becomes equals to right, because right is also equals to 1. So then we insert at position 1 our value, so we get this. Now let's check when we only have our first element is 1, our first element is 2, and our second element is 1. In that case, again length is equal to 1, and then here our mid is the first element, which is equals to 2, and we know 2 is greater than 1, right? 2 is greater than 1, so right is equals to our mid. So basically right becomes equals to 0. Now left and right both becomes equals to 0 here, so we exit from this while loop and then we insert our element, a new element at index 0. So our element is inserted here. So far this this function is all right, so we do not need this element line, so I'm just remove that. And now we need to find the median. For that we need the middle value, which is equals to m equals to mat dot float this dot array dot length divide by 2. So we are gonna take the middle value here, and now if the size of the array is even, then we are gonna return the average of 2 middle elements, right? So that is when we are gonna do m plus this that array m minus 1 and take the average of these, that is divide them by 2, else we are just gonna return the middle element. So I'm doing here m minus 1 because let me just show you in this example here. So we have one more element here, which is equals to 2. So in this case the length is equals to 4, so the mid value is equals to 2 here, 0 1 and 2. So this becomes our mid, and we know the median is equals to these two elements, right? The sum of average of these two elements, and our mid value and the value of m is equals to this. So that is why I'm doing m minus 1, so that we take the sum of these two elements and divide them by 2, which is the average, and return that value. Now let's run our code here. Okay, all right, let's submit this code. Great. You could see the time complex runtime is still very high, right? Well, this is not the completely optimized solution, however this is one of the better solutions so far. Now let's see on another method we could solve this problem. So we saw an array method, right? The another way to solve this problem is using linked list. So how could we use linked list? Well, basically linked list is we are going to use singly linked list when one element points to the next element, and that points to the next element, and the last one points to the null pointer, right? So suppose our first element is 1, so this will be our head. Our head will always be pointing to the first element in the list. And now every time we add a new node, let the new node be equals to 2 here, and we know 2 is greater than 1. So it means that 2 must go after 1, so we are gonna point 1 to 2, and let us suppose that next element in our data stream is 0. So what is 0 greater than 1? Of course not. 0 is not greater than 1, right? So at that point of time, what we need to do is we need to change our head, because 0 comes before 1. So 0 will come before 1, and this will point to 1, and now our head will point to 0. And next, when we are adding a value, suppose a 1 again, here we know 1 is greater than 0 and less than 2, so basically 1 will come somewhere here. Why not insert 1 here? So as long as we need to at that point of time we need to traverse the list, and as long as the current element is less than this value, we are going to traverse the list. And once the current element becomes greater than or equals to that value, that is when we know we need to insert at that position, right? So that is what we are gonna do. Let me show you another example. Suppose in the list we already have a value 1, a value 2, a value 4, and our new element is equals to 3. We need to add this element. So this is our head. Our head is never gonna change. This is our head. Now my current pointer, and my previous pointer, I'll need a previous pointer and my current pointer. My current pointer will be pointing to my head, and my previous value initially will be equals to null, so it will be pointing to null. Now I know my current pointer is pointing to 1, which is less than 3. So now I shift my current. Now my new current is equals to 2, but before shifting my new current, I'll shift my previous pointer. So what happens here is here my current is 1, which is less than 3. So what I do is I need to traverse the list. So I might change my previous to my current, so this becomes my previous, and my current is changed to the next of the current. So this is my new current and this is my new previous. This is my new previous, and again my current is less than 3, right? So I again change my previous to my current, and my current is changed to the new to current at next. Now here current is greater than 3, so we know that now we need to insert our new element between previous and current. So what we gonna do is my previous will point to 3, the next of the previous is 3, and the next of the 3 is equals to current. So this will be removed here, and our new list will be this one. So 1 to 2 3 and then 4, that is what we need. And one more thing is that we also need to keep track of the size of the linked list, so that we could find the middle value. So every time we add an element to the linked list, we are going to increment the size of the linked list. Now let's implement this solution as well. So I'm just going to refresh this, reset it to default, and then start coding. So in order to create a linked list, we need a node class function with a value, and then this dot val equals to value, and this dot next pointer will point to null initially, and then here we are gonna define our head, which will initially be equals to null, and the size, which is to 0 initially. And then when we are adding our nums, we need to increment our size, and what we need is we need previous value, which will be equals to 0, and then current, which will be equals to head, right, which will be pointing to head. And then we will traverse our linked list as long as num is less than the value of current. So as long as a num is less, a current is equals to current dot next, and previous equals to current. Before we change our current, we need to change our previous to current, and then current is equals to current dot next. Now if in case we found our previous is pointing to some value, which means that we have found a position, a previous and a current, which means that previous should point to the new value and new value should point to the current. So that is when previous dot next equals to new node. Okay, I need a new node. I need to define our new node, create a new node. So let new node equals to new node with value num. So it will point to new node, and new node will point to current. Now if in case we did not find our previous, that is when okay, the value, we are actually comparing our value. So that is when we do not have our current, that is when head is null. So it is the case when we are inserting our first element. So when we are inserting our first element, or inserting an element at the very first, and let me just show you an example. So suppose now we need to insert an element, a new element, which is equals to 0, and we know that 0 is less than 1, right? 0 is less than 1, which is the first element here, which so 0 is less than 1, which is our current element. So we need to insert 0 before our current element, right? So that is when our previous is still null. So next of previous will basically be 0. Basically we don't need to do this. So in this case the 0 will point to current, and our head will point to 0. So in this case our new node next will be equals to current, and then our head is equals to previous equals to new node. And to find the median, we need to find the middle value. So math dot floor size minus 1 divided by 2, and then if let median value equals to, okay, equals to 0, and then we need to traverse through it. Okay, so let count equals to 0, and while count is less than m, we also need a current equals to height equals to current dot next. So every time, and count, we are increasing our count, so that is when we reach our middle value, our count is equals to m. So our median will be equals to current value. And now if in case it is the size is even, if the size is even, so modulus 2 equals to 0, that is when median plus equals to current dot next dot value. So we are adding the next value also, because the median is the average of the middle two values, right? So that is what we are doing here. And then median divided by equals to 2, so I'm adding those two and then dividing them by 2 to get the average of the two values, and then finally return the median. Okay, so where is this? Talking about the time complexity, the time complexity of this while loop is equals to O of n. Okay, something went wrong here. Okay, so what went wrong? Let's just see, check that out. Okay, so when I'm inserting my first element, which is equals to 1, at that point size becomes equals to 1, I create my new node. Previous is null, this that head, which is also equals to null. So my current is null, I do not have a current, so this while loop is not executed. So my previous is null, so when previous is null, that is when my new node, next of my new node is pointing to current, which is equals to null, so that's fine. And my head is equals to new node, so basically my head is new node and the new node is pointing to current, which is equals to null. That's totally fine. Now if I need to insert a new element to size, increment the size, create a node, and then previous is 2, current is equals to head, which is equals to 1. Since we have a current and the value 2 is 2 less than the current value. Oh no, actually it should be this way. Yeah, so while the value current value is less than 2, we are gonna traverse the node. So my previous becomes equals to current, so this is equals to current, and now my current is equals to null. And I do not have a current value, so my previous was equals to 1, right? So the next of 1 becomes my new node, so 1 is pointing to 2, and then the next of new node becomes current, which is pointing to null. So this would be the correct solution now. Okay, it's still not working. Why is that? Let's check it once more. Now suppose my new element is equals to 0. In this case, my current, which is also pointing at head, is pointing at 1. So, and my value of norm, which is 0, is less than the current value, right? So this while loop is not executed. Some previous is null. So this if condition is becomes equals to true, and then this code is executed. So new node that next is equals to current, which is equals to the head, and then this the head is equals to new node. So basically a new node next is equals to current, and then height is equals to the new node, so this becomes my new head. This seems totally fine. Let me just debug this. Okay, so this is just num here. Let's run our code now. Alright, so far I was doing the right thing except that one thing. Let's submit our code. Talking about the time complexity, the while loop is O of n. So this is O of n time complexity, and the find median is also O of n because we are finding the middle value. Basically it's O of n by 2. So the total time complexity is O of n, which is huge. So from here, this is the array solution, this is the linked list solution, and we can see the time runtime. So array solution is far more efficient than the list solution here. In my next video, I'll actually talk about how we could solve this problem using heap, mean heap and max heap. So stay tuned for that.